to represent Moscow Transport Research and Development Institute here in Delhi. So I'll tell you about an idea of LRT development in Delhi as a part of complex urban strategy. Our general approach as a project institution to the development of transport strategy is based on three main principles. First of all, we collect all the data available in open source sources like internet, government data, and mass media. All data collected is then analyzed and first proposals are developed. In case of Delhi, there are three main proposals concerning transport development. Development of existing public transport, proposals for new public transport. We suggest building an LRT system and road traffic organization. To prove the efficiency of our proposals, we've built a Delhi basic macro model and also micro models for specific intersections and road segments. This model is used to calculate the positive effect of our suggestions. The most important part of our proposals is development of LRT net as a new public transportation system that is better than buses, and as Mr. Duby said in his presentation, can substitute metro in some cases. As elements of general transport strategy, we also suggest some actions regarding buses, toll parking, traffic flow management, and road development. So, the most powerful tool available to a transport analyst is a transport model. This is a picture of a basic macro model of Delhi city, which we use to reveal the main problems. It contains about 350,000 segments of streets and roads, more than 130,000 of intersections, and 763 areas with unique social and economic characteristics. The model is used for transport planning, urban design, and analysis of road development effects, including arrangements that require road narrowing. And also the model is very useful when calculating passenger flows, for example, while changing bus route network or consider building a new LRT or metro line. Finally, the model helps to evaluate the effect of traffic management changes and toll parking implementation. As we see at the picture, the model shows us that most traffic problems of Delhi city are concentrated in central area. So we consider that extra passenger capacity is needed in the center, and priority measures, including LRT construction, should be implemented there. There is a little comparison between LRT and metro. Both LRT and metro are high-capacity rail-based guided transit systems. Metro is completely isolated and thus provides maximum speed and passenger capacity. LRT, on the other hand, is flexible and combine on-street running and segregated tracks in one route. So, we already mentioned that LRT lines could be very different depending on the area where they are built. Usually most part of the tram net consists of segregated tracks on surface. For example, for central districts, special tram and pedestrian zones could be organized like on the upper right picture. As was also said, for when constructing the LRT net, also could be used tunnels or overpass segments where needed, for example, to cross major roads, railroads, rivers, or to achieve better integration with other modes of transportation. There's also a variety of modern constructions, track construction types for LRT that are good, that suit any kind of environment. For example, for historic areas, we consider the areas, the grass covering could be applied both for aesthetic and noise reduction purposes. Also, there is a big variety of rolling stock manufacturers for LRT that offer state-of-art modern trams. The tram consists of several sections with usually low floor and multiple doors that offer fast boarding and comfort. A decent number of seats and air conditioning system provide comfort for the passengers during the trip. Modern bogies with two-stage suspension reduce noise and vibration caused by trams, both inside and outside. And all modern tram cars are designed for at least 30 years of service life, so it's a long living decision. To maximize the effect of LRT, the tram should be given priority on most road intersections. This makes LRT reliable and rapid public transport service without need to build overpasses and tunnels, and thus is highly cost effective. Here's an example of how Delhi LRT network could look like. We chose the widest streets available in most highly developed areas. As we have mentioned, there is a lack of transport supply in central districts, so all lines are heading city center. All lines also do not follow metro lines, but consider sufficient number of transfers between, and on some segments offer extra passenger capacity where metro lines are overloaded. The net we designed connects a variety of city attractions and points of interest, including both railway stations, stadiums, business districts, and other objects. As an example, places for new tram depots could be located next to existing metro depots to unite the facilities. So, combining off-street and street running segments in a united network, LRT offers maximum coverage and comfortable transfers to metro, rail, and bus services. Our model shows that suggested LRT lines would be quite in demand, mostly in central and southern parts of the network. Also, we think that proposed lines could decrease the overload of certain metro lines, and total daily ridership we estimate at around 200,000 passengers per day. As a part of a complex daily transport strategy, we also made a brief analysis of other transportation services in Delhi. For example, we found out that there are several districts with low coverage by buses, mostly that are located in the northwestern part of the city. We suggest adding more bus stops in those areas and possibly create some new bus routes. As buses are overcrowded in peak hours, as you could see, we consider the peak frequency of bus services also is to be increased. As the outcome, we expect ridership increase in around 10%. The city center is quite congested by traffic, and at the same time, it is the city center where a lot of points of interest is located, including social, educational, and government objects. To reduce congestion and increase mobility, we suggest introducing a parking management system that includes toll parking and stationary and mobile cameras to control parking rules. Toll parking should be implemented in central and airport zones as the most congested. We suppose that these measures would reduce congestion by around 12% and attract people to public transport, which would also work much better. Also, with implementing toll parking zone, it is reasonable to create more pedestrian zones in the central districts to encourage walking and cycling. The model also shows that there are some points of congestion beyond city center. These are subject to change of traffic organization and traffic light changes. These are subjects to implementing bus lanes and zones with prohibited parking that should be equipped with cameras. We suppose that such actions could lead to the reduction of traffic accidents with injuries by 15%, and as a part of a complex transport strategy, it's reasonable to develop city road network, creating new communications, especially in the peripheral part of the city. Such new road segments lead to overrun and congestion decrease by 10% on adjacent roads. We consider as a first step building 2 new roads between Shivaji Road and Manohar Park, and between Dev Prakash Shastri Road and Ring Road. This would, our estimate is that would decrease everyday overruns for total 36,000 people respectively. Also, we took a look at accessibility of the city center by individual transport. The modal data shows that on the northeast and southwest of the city center are hardly reachable zones, and main efforts in transit development in general should be implemented in these directions. Our state unitary enterprise MOSGORTRANSNIIPROJECT project specializes in design of comfortable urban environment, including tram lines, bus networks, rail and metro infrastructure, road management and parking design. We are the biggest Russian transport R&D institute that designs transport in Moscow and other Russian cities for over than 70 years. Thank you for your kind attention.